This is video 1 of the Psych 642 categorical data assignment. I'm going to begin by briefly discussing what this family of tests can do, when it should be used, how it works, and what it needs in terms of data and assumptions. And then we'll move into the data, the research question, and the analyses. So first of all, this specific family of tests can determine whether a relationship exists between two or more categorical variables. So as far as when it should be used, it should be used when the research question that you're trying to address involves two or more categorical variables, and whether you're looking for a relationship between those variables. So these tests work by looking at the frequencies within each group. So rather than, for instance, if we're looking at continuous variables, looking at the mean, we're going to be looking only at specific categories. So we're going to be looking at the frequencies within each of the categories, and comparing whether the frequencies we see are different from the frequencies that we would expect just from random chance. And that's, in a nutshell, how we determine if that relationship exists, is by comparing the expected frequencies to what we actually see in our sample. So what this group of tests needs to work correctly is, as I've said multiple times, categorical variables. So all of the variables that are involved in this type of analysis are categorical. There are no continuous variables. As far as assumptions, we still have the assumption of independence, which basically just means that every person needs to contribute to only one cell of the contingency table. And then the second is, for each of the possible combinations of variables within your contingency table, you're going to need to have an expected frequency of greater than 5 in order to run this test. So that concludes just a very brief introduction to this family of tests and what we need in order to be able to run it. So for this assignment, the research question that I'm interested in is just simply, is there a relationship between the variables of class, how often someone prays, and the subjective report of whether or not they're happy. So all of these are categorical variables. So class, I'm specifically just going to be looking at lower class and middle class. So everyone that is involved in this study will be in one of two of those categories. Specifically looking at how often someone prays, I'll be looking at two options. Do they pray at less than once a week, or more than one time per day? So that's the two options specifically that I'll be looking at in this study. and then happiness will be either someone has reported that they're pretty happy or not too happy. So everyone involved in this research will pick one of the two of each of those categories. They'll fall into one or the other for each of the three variables. So because each of these is a categorical variable, and I'm looking at three different categorical variables, I'll be doing a log linear analysis, followed by kind of some follow-up chi-squared tests in order to better understand the findings of the log linear analysis. So now let's take a look at the data really quickly. So I'm going to just import that into R. Okay, so you can see that I have the three variables here. Prayer, which is how often someone prays, and you can see the two options: several times a day or less than once a week. So kind of the two extremes here is what I'm looking at. Happiness, whether someone's pretty happy or not too happy, and then class, specifically whether someone is lower class or middle class. So now that I have the data set up and imported into R, I can go ahead and finish setting up for the rest of the analysis. So I'm going to open my script file. And before doing anything else, as always, I have to load the packages necessary for the analysis. So I'm going to do that using the library function. The first package that I'm going to load is the gmodels package, which has the functions necessary for doing chi-squared. And then I'm going to also load the package for the package mass, which is necessary for the log linear analysis. It has the functions for that. So both of those have been loaded for use. And now I'm going to attach the data set using the attach function so that I can use the data set for the analysis. And now we are ready to go. So I'm going to go ahead and clear the console to get this stuff out of my way. And now we are ready to begin the log linear analysis. The first step of this analysis is to use the xtabs function to create the contingency table that includes the information for all three of these variables. So you can see the three categorical variables listed here, and the data is coming from the dataset prayer, which you can see over here. So I'm going to go ahead and run this to create the contingency table. And then here we can see the contingency table that we've set up. So now that that's been done, I'm going to create the saturated model. So the saturated model is the model that contains all of the effects and explains everything perfectly. It perfectly explains the data. So I'm going to use the log lm function to set up this model, and then I'm going to do all of the effects, including all of the possible interaction effects between prayer, class, and happy, as in addition to the main effects. And the data is going to come from the contingency table that we just set up. So I'm going to set that up, and we can see, if we look at a summary of that, we get a p-value of 1, indicating that this is the saturated model that explains the data perfectly. So next, I'm going to start taking out different effects, different elements. The first, starting with the highest order effect, which in this case is the three-way interaction between prayer, class, and happiness. So I'm going to use the update function in order to remove this interaction and create a model without that interaction in it. And then here we can see the likelihood ratio for that new model. And I'm going to use the ANOVA to compare the two models. Now, that seems kind of silly for this one, just because if we're looking specifically at the change between the models, we can see that it's everything here is 0. So as we'll see in just a second, it's going to come out to be pretty much the exact same thing as this minus, all of this. The 2.71 minus 0 and the 1 minus 0 gives you your degrees of freedom. And then this is the significance value of our change, which we see is not significant. So this means that I will now continue to remove effects, and the next highest order effect would be the two-way interaction. So I'm going to remove each of these one at a time in order to see if any of them are significant. Once again, I'm going to do this using the update function. I'm going to update the three-way model that I just created 3 different times. And I'm going to start with removing the prayer and class interaction, and then use the ANOVA function to see if that is significant, which we see that it is significant. Then I'm going to do the next one, prayer by happy interaction. We see that it is not significant. And then the class by happy interaction, which we see that it is significant. So 2 of the two-way interactions are significant. Prayer by class and class by happiness. So the next thing I'm going to do is I'm going to do chi-square chi-square tests in order to understand those interactions a little bit better. So that is going to be where I pick up in video 2, is with those chi-square tests.